Hello everyone, this is Hidayat Shahid. I'm your lab instructor for MECE2310 Concurrent Engineering and Design course. In this instructional video, I will walk you through your lab exercise 2A and 2B, which is basically 3D modeling of rack and pinion mechanism with the motion simulation. So your assembly of this mechanism looks like this. So you will model all the parts, and then you will assemble them, and then you will do the motion simulation. I'm going to open up the Solidwork Assembly, which I have already created. So basically, you can have a look at the assembly. So there's basically a few components. You have this ball joint, you have this rack, you have this gear cover, and inside the gear cover, you have gear, which I'm going to simply change the transparency for this cover so you can see the gear, which mates with this rack. And when the gear moves, it will produce the motion with the rack as well. So this is basically the assembly, and this is all you will create. The lab is designed divided into two sections. Lab A, in which basically you will complete the part modeling. In lab 2B, you will create the assembly and you will do the motion simulation. To start this lab exercise, I'm going to simply open a new file and I'm going to save it. I'm going to click OK. First thing first, as our normal practice, you will change the units to mmgs, and then you will save this file as. I have already created this folder lab 2 and 2b, so I have everything created in here. So in your case, for all the components associated with this lab, please create a folder lab 2a and 2b inside your working folder for MECE2310U Labs with your student IDs. For all the components which are created in this video, please make sure to save them as lab 2a for the components, and for the assembly, please create it with the name as lab 2b. In the instruction video, you may notice there will be lab 5 will be mentioned in the Solidwork part files. This is due to the fact that we have been using this lab as lab 5, but we have shifted on this lab to lab 2 for your course because we have added new labs this year. So please ignore those names. Please ensure to save. Again, I want to emphasize, save all the files under your lab 2a student ID and the component name for that part file or the assembly. So for example, I'm just simply going to give this file name as lab 2a, and for example, if my student ID is 56099, something like that, and I will save this file as gear cover. Okay, so this file is extra on my folder, which I will delete after I have shown you a couple of things. So first thing that I will do is I will select this top plane, and I will click on this normal to, and I'm going to create a sketch. On the sketch, the first thing I'm going to create is a center line. The center line, I'm going to start here, and I'm going to escape. I'm going to click on center line there, and I'm going to go across here. And with this one, I'm going to add some dimensions. The dimension that I want to add in here is, I'm gonna do equal sign. It's getting these dimensions from your figure 6 in your lab manual. I'm gonna use 25 plus 0.5 times 25, and I'm gonna click OK. So this is 37.5. I'm just using an equation in there, and this dimension I'm gonna use as, I'm gonna put equal sign, I'm gonna define as 65 plus 45. Okay, I'm gonna click OK to that. This kind of put things in perspective how I want to lay out my 2D sketch. So I'm gonna go to this circle 2D sketch tool. I'm gonna select something in here. I'm gonna drop one sketch there. I'm gonna drop one sketch there. I'm gonna drop one circle there. And next thing what I'm gonna do is I'm gonna select this circle, I'm gonna press and hold my control key, select this, and I'm gonna make them equal. And the next step what I'm gonna do is I'm gonna add a dimension. The diameter for this circle is 25. Since all of them are the same, so they have been defined like that. Now I'm gonna add some dimensions from center point to center point. The distance is 25, so they are touching each other. And same thing I'm gonna do is between these 2 points. I'm gonna specify this as 25. The next thing I'm gonna do is I'm gonna add another circle somewhere here. I'm gonna specify the diameter for that one as 65, and I'm gonna add the dimension between this center point to this origin. It is specified at 65. Alright, and the next thing what I'm gonna do is I'm gonna add another circle here. And I'm just gonna drop it there, and I'm gonna add the dimension for that circle. The diameter in your manual is specified as 25 millimeters. I'm gonna just drop this in here. And the next thing I'm gonna do is I'm gonna add a couple of straight lines. I'm gonna go in here, select this point. I'm gonna come across somewhere there, and I'm gonna drop it, escape, and I'm gonna add another line here, and then I'm gonna come across somewhere there. Let this line up, escape, and there is 2 more lines I'm gonna draw, which is gonna come from this side and intersect this circle. Gonna come across here, horizontal, escape, and I'm gonna come back horizontally here. I'm gonna hit escape key, and now I'm gonna trim some entities that are not needed. One thing I have not added, I need to add a couple of lines that intersect these two. So I'm gonna add 2 vertical lines. I'm gonna start somewhere there, and I'm gonna drop somewhere there, escape, and I'm gonna do on the vertical side too. I'm gonna come from here, and I'm gonna drop in here. So now this sketch is more or less similar as what is shown in figure 65. I may have slight differences the way I have added the dimensions. One thing I notice in here, this line I have drawn at an angle. So what I'm gonna do is I'm gonna click on this, and I'm gonna make it horizontal. And while I'm at it, I'm just gonna make sure that all the things are horizontal. Okay. Now I'm gonna go to the trim entities tool. I like to use this power trim quite a bit. Now I'm gonna start deleting the items that I don't need to make figure 6 a sketch. So what I'm gonna do is I'm gonna grab this, delete that, and in this one I'm gonna delete this side, and on this one I'm gonna trim this. My sketch is overdefined because of some of the dimensions I have created to create the sketch, which I will clean up. The next thing what I'm gonna do is I'm gonna trim this, and I'm gonna trim this, and I don't need this, I don't need that one, and I don't need this, and I don't need that. I don't need this one, and now what I'm gonna do is I don't need this, and I don't need this. I am gonna delete this one, and I will get rid of these. So now if I look at the sketch, it looks like more or less what I have in figure 6, but my sketch is overdefined. These yellow ones, I know I could delete some of the dimensions to remove the over definition. So my sketch is no longer overdefined, however it is underdefined now. So what I'm gonna do is to fix that, I'm gonna add a couple of dimensions to see. Okay, this will overdefine as well. What I'm gonna do is I'm gonna delete this, and I'm gonna add this dimension. Click OK, and what I'm gonna do is I'm gonna define from this point to this point, specify the dimension there, 65. So as you can see, my sketch is now fully defined. It's extremely important to fully define your sketches when you are you're supposed to do some assemblies. The next step, what I'm gonna do is I'm gonna use Extruded Boss base tool to create the solid body. According to your lab manual in figure 7, the depth of the extrusion is 50 millimeters, and it's blind. I'm gonna click OK. In the next step, what I'm gonna do is I'm gonna add a couple of fillets to round off the corner, this edge and the opposite side edge. To do that, I'm gonna click on fillet feature, and I'm gonna specify the fillet radius as 5 millimeters, and I'm gonna select this edge, and I'm gonna rotate my model, and I'm gonna select this edge. I'm gonna click OK. So now it has been rounded off that corner. In the next step, I'm gonna add a circle on top of this face. I'm gonna click normal to it. I'm gonna go to sketch, and I'm gonna click OK. So and I'm gonna add this circle. To add the circle, what I'm gonna do is I'm gonna just drop it somewhere in here, and the I'm gonna click OK. I'm gonna add the dimension for the circle. The diameter for this circle is 60 millimeters. I'm gonna click OK. One thing I'm gonna do is it's not fully defined. I'm gonna get rid of this dimension dialog. I'm gonna select this, press my control key and select this edge, and I'm gonna make this concentric, and this will fully define my sketch. And now I'm gonna go to feature, and I'm gonna extrude it. I just want to make sure that it's on the right direction, and the extrusion distance is specified as 20 millimeters. I'm gonna click OK. So this is done, and in the next step I'm gonna select this face, and I'm gonna add a sketch there, and I'm gonna look normal to that. And in here, this refers to step 10 in your lab manual. I'm gonna add a sketch. I'm gonna go to sketch tab, and I'm gonna select this circle, and I'm gonna drop a circle in there. And in here, the dimension for this circle is 50. The diameter is 50 millimeters, and the position of this circle, the center to this edge, is 25 millimeters, and the next between this edge and this point, it's specified as 32.5 millimeters. So this fully defines the sketch, and I'm gonna go to the feature. I'm gonna add another extrusion on this one. The depth is 20 millimeters, so I'm gonna click OK, and I'm gonna add another one of this extrusion on the other side, but I will use mirror feature for that. And mirror face or plane, I'm gonna select is front plane. I'm gonna click OK. So I have added that. Now I will move to your step 12. In there, I'm gonna select this face. I'm gonna click on sketch, and I'm gonna look normal to that face. And I'm gonna add a circle there, and I'm just gonna drop it in here somewhere. I'm gonna use the smart dimension, and the diameter for that circle is specified as 50 millimeters. Now I'm gonna do is I'm gonna center this circle to line up with that, so that the center of circle is the same. I'm gonna select that, control key, select this, and I'm gonna make it concentric, and that fully defines my sketch. And I'm gonna go to the feature tab, and I'm gonna make a cut, and I'm gonna rotate the model. The direction is correct. The depth of cut for this method that you need to use is basically do a blind cut for 50 millimeters, and I'm gonna click OK. So there we go. In the next step, I'm gonna select this face. I'm gonna add a 2D sketch on that. Gonna look normal to it, and I'm gonna draw a circle there with the diameter is 50 millimeters. 50. Now actually this is the diameter is 38 in step 14. Yeah, that looks more like it. So I'm gonna position this circle, make them concentric again, and that will fully define the sketch. And now I'm gonna do a cut through all that body, and I'm gonna specify through all both, and I'm gonna click OK. So basically I have cut the hole across. Now I will move on to the next step. In the next step I will add 3 holes, one there, one there, and one there. So what I'm gonna do is I'm gonna click sketch, and I'm gonna look normal to that face, and I'm gonna add 3 circles. I'm gonna line it up here, I'm gonna line up there, I'm gonna line up there. So what I'm gonna do is I'm gonna add some sort of relationship among those circles because they're the same size. I'm gonna select this, control key, select this, control key. I'm holding it down. I'm selecting all the 3 arcs, and I am making them equal size. And I'm gonna specify dimension only once. The diameter for this circle is 12 millimeters. But I'm gonna position these arcs concentric to these arcs. So to do so, I'm gonna select this one, press and hold control key, and I'm gonna make it concentric. I'm gonna select this, press and hold control key, concentric, and I'm gonna repeat the same thing with this one, and concentric. So my holes are positioned, my circles are positioned properly, so now I can and do the cut. So to do that, I'm gonna go to feature, extruded cut. This is a through hole. You could just specify blind 50 or you could do through all, but I'm just gonna click here because it's already set, so it's a through all hole basically. Yeah, actually I'm gonna go through all because I don't like alright, so now if I rotate it around, it's clean this way. Okay, so the next step I'm gonna create, there are 2 grooves on these cylinders which I will add. To do that, what I'm gonna do is I'm gonna select this face and I'm gonna go sketch, and so I'm gonna press spacebar key and I'm gonna look normal to it. And now I'm gonna do is look at convert entities, and I'm gonna select this outer edge and I'm gonna click OK. This has created this circle there, and I'm just gonna rotate it on the sideways so you can have a look at that. And now I'm gonna make a cut. I want to create a groove in there, so I'm gonna go to the feature tab. I'm gonna click on extruded cut. In this one, I'm gonna select the method as offset. In here, I'm gonna specify 6 millimeters. And for blind, I'm gonna specify the depth is 6, and I'm gonna click on this thin feature. I'm gonna specify the thickness for this as 2.5. So now what I'm noticing is on this one I would like to change the direction. To do that, I'm gonna do is change the offset direction so the cut goes towards inside, and I'm also gonna change the direction for this so that the cut is removing the material rather than pointing towards the outside. I'm gonna click OK. And with that step, I have created that groove that is specified in your manual. Now I'm going to create the groove on the other side, but I will use mirror feature for that. I'm going to select mirror. For the plane, I'm going to select the front plane. And features to mirror, I'm basically going to select this thin cut extrude that I just completed. I'm going to click OK. So basically this is almost getting complete. In the next step basically is step 19. I'm gonna select this face inside, and I'm gonna click on sketch, and I'm gonna press space key, and I'm gonna look normal to it, and I'm gonna sketch 2 concentric circles somewhere here, 1, 2. and I'm gonna add the dimensions. The inner circle is, the diameter is 10 millimeters. The outer circle, the diameter is 20. And one thing I would like to make sure that this is concentric relationship between this outer cylinder. To do that, I'm gonna click on one of the circles, press my control key, and keep holding on to the control key and select this arc. Oops, it didn't do it properly, so I'm gonna select it again. Control key, hold it down, press this, and select this, and I'm gonna make them concentric. So this defines the sketch. So the next, what I'm gonna do is I'm gonna use the Extruded Boss feature, and the depth that is needed for this step is 5 millimeters, and I'm gonna click OK. So I have added that, and the last step, basically we need to add a fillet, which is specified in figure 22. To do that, I'm gonna go to the fillet tool, and I'm gonna select add radius of 2 millimeters, and items to fillet, I'm gonna pick the outer edge, which is right there, and click OK. So this basically completes your gearbox. I'm gonna save, and I will move on to your next component. So for part 2, I'm gonna open up a new part file, and I'm gonna change the units as mmgs, and I'm gonna save this file as, I'm gonna select lab 2A. I'm gonna create with my you should create with your student ID, and this name will be cylinder rack. I'm gonna save. To start the part, I'm gonna select the front plane, and I'm gonna click on sketch, and I'm gonna sketch a circle right at the origin, and I'm gonna set the diameter for this as 38. That's shown in figure 24, and the sketch is fully defined. I'm gonna go to the feature tab, and I'm gonna extrude it using mid-plane method. Mid-plane, and the extrusion depth is 400 millimeters. Click OK, and I'm done. The next step is I'm gonna add a hole on this side and on the other side. Okay, to add the hole, what I'm gonna do is I'm gonna go to this hole wizard, and I'm gonna select hole type as simple hole, and standard I'm gonna set as DIN, and the type is drill size, and the hole specification, the diameter is it's 15 millimeters, and the depth of that is set at 50 millimeters. So and the angle at the bottom, which is specified in your manual, it is at 118 degrees, which is, I set it over here after clicking by checking this box that shows custom sizing. So I am done that. Now what I'm gonna do is I'm gonna position this hole. So I'm basically gonna click on this, select this face, and I'm gonna line up with the center there, right click, and the hole is created. And I'm gonna repeat this same step on the other side, and I'm gonna click on here, And my parameters that I used the last time, they are basically set, but I'm gonna double check with the show of custom sizing, which checking this box. So everything is the same. I'm gonna go and position the hole on this side. I'm gonna select this face and I'm gonna line up with right there in the middle. Right click. So I have added the 2 holes. Now what I'm gonna do is I'm gonna add some threads. To do that, I'm gonna go under insert and I'm gonna go under features, and in here I'm gonna look for threads. So this thread tool I have activated, and I'm gonna click OK to that. So basically in this one, the specifications which are specified in step 26 of your lab manual, I'm gonna select this edge, and let's see if I can do both of them at the same time. No, I can't. It only does one at a time. So I have selected that. The depth for this one is needs to be specified at 50 millimeters. The end condition is blind, and the thread options, I'm gonna specify right-handed thread. The angle is not specified, so I'm gonna leave it as 0. And one thing that I'm gonna do is I'm gonna trim with the start face, face, and the die is set as metric die. So my parameters are pretty much specified. I'm gonna click OK. Since it's saying unable to cut threads on cylindrical surface, use external threads instead. So always check, because my hole size is bigger than the thread size. So to add threads, there is no materials that the software can remove. So I'm gonna go with extruded threads. Gonna click OK. So the threads have been added. I can just zoom in so you can see. The next side, I'm gonna add threads on this side as well. To do that, I'm gonna go back to insert, features, I'm gonna looking for the thread right here, and I'm gonna select this edge, and I'm gonna leave the specifications the same, but I'm gonna just check this box, and I'm gonna trim with start face, and I'm gonna click OK. So the threads have been added on both sides. You can verify this by just looking at your wireframe. So the threads are there. So I'm gonna turn back my shaded view, and now what I'm gonna do is I'm gonna select this right plane. I'm gonna look normal to it, but I'm gonna rotate this part so that it's consistent with the manual. So I'm looking at the right plane, normal to it. Now what I'm gonna do is I'm gonna make a cut, and to make a cut, it is specified in your figure 28. That will create the path where the rack will be added. So right click, and I'm gonna add a sketch on it. To add the sketch, what I'm gonna do is I'm gonna just use a rectangle, and I'm gonna go somewhere here. So the specifications, now I'm gonna add some dimensions. This dimension is 200, and from this point to this region is 10 millimeters. So the next dimension that I'm going to add is it's basically between I'm going to add it between this dimension and this origin. I'm going to set this as 100. So this will set this in the middle, and I'm done with my sketch. So I'm going to do a extruded cut. I'm going to do both directions through all both, and I'm going to click OK. So a cut has been made. So then the next step, what I'm going to do is I'm going to cut some teeth along this edge. To do so, I'm going to pick this right plane, and I'm going to click on the sketch, and I'm going to add the 2D profile for the tooth. To do that, what I'm going to do is I'm going to basically come here. I'm going to draw a line there, go in the middle, and close this profile like that. And I'm going to also add one center line there. Now I'm going to add some dimensions. I'm going to select this edge, select this point, and I'm going to keep this dimension as 14 millimeters. These dimensions are shown in figure 30. From this edge to this point, it is 7 millimeters. And one thing I'm gonna do is I'm gonna add a relationship in here, this one, and I'm gonna hold in my control key, and I'm gonna try to reach this point, and I'm gonna make them coincident. The next thing I'm gonna add is the angle dimension. I'm gonna select that edge and this edge, and this angle is supposed to be 120 degrees. So as soon as I have done that, my sketch is fully defined. What I'm gonna do is I'm gonna go to features, and I'm gonna click on Extruded Cut, and I'm gonna pick through all both and click OK. So basically this has been added. In the next one, what I'm gonna do is I'm gonna copy this feature along this edge. To do that, I'm gonna click on this linear pattern, and the feature to pattern, I'm gonna select this cut extrude, and the direction I'm gonna specify this one, and number of instance. In the lab manual it says it's supposed to be 15, but I believe it's supposed, in the figure it shows 15, but it needs to be 16. So I'm gonna specify 16 here, and feature, select that. So this is the view. The distance between the teeth is the pitch is set as 11.5 millimeters. Oops, I'm specifying on the wrong side where I don't need that. Actually, I gotta clear this selection. Actually, I gotta select that. So the preview is there, so I'm gonna click OK. So basically this completes this part. I'm gonna save this part. Now I'm gonna create part 3. To do that, I'm gonna open up a new part file, and I'm gonna click OK. And in here, I'm going to change the units from IPS to mmgs, and I'm going to save this file as in the working folder, and I'm simply going to use the Lab 2A student ID, and I'm going to name this one as ball joint. save. The first thing I'm going to do is I'm going to select this top plane and I'm going to create a sketch. I'm going to click on this circle icon and I'm going to select the origin and I'm going to create this 2D circle, and I'm going to specify the diameter for this circle as 120. 120 millimeters. The next thing what I'm going to do is I'm going to draw a center line, because I like to see my references where they are. And what I'm going to do is I'm going to draw a line somewhere and I'm going to come down like that. What I'm going to do is the following. I'm going to extend this line actually here. I'm doing slightly different than the way it's described probably in your lab manual, but what I'm going to do is I'm going to trim this. I'm going to trim this for now. I'm going to set this distance 35/2. Okay, so that's done. From center point to this edge, I'm gonna set this as 70, and and I'm gonna trim this section. I'm gonna click OK here. I'm just gonna delete this dimension because I just want to double check my dimensions. So I'm gonna delete that. I'm gonna select this one and my center line. I need this to be as 35/2. So that's done, and I'm gonna drop in one solid line there, and I'm gonna escape, and I'm gonna mirror this profile sketch along the center line. I'm gonna select this line, and mirror about this. So basically my sketch is done. What I'm gonna do now is I'm gonna basically go to features. I'm gonna extrude this, and the depth for extrusion is specified as 25 millimeters. I'm gonna click OK. In the following step, I'm gonna create a sketch which is shown in step 36. I'm gonna select this face and I'm gonna basically look normal to it, and on here I'm gonna draw a 2D sketch. The 2D sketch, basically what I need is it's basically a circle. The dimensions for the circles are the diameter is 15 degrees. From here to this is set as 12.5, and I'm gonna add a relationship for this one. I'm gonna select that and hold my control key and then select this point, and I'm gonna make them vertical, and the sketch is fully defined now. So basically the next step what I'm gonna do is I'm gonna go to features and I'm gonna use Extruded Boss base, and the extrusion length for this step is 100 millimeters. Now I will add threads on this rod that I have just created. To do that, I'm gonna go to Insert, Features. I'm gonna get out of this sketch. Insert Features. I'm gonna go to Thread Tool, and in here I'm gonna select this edge, and the parameters that needs to be specified for the thread is basically it is M32, and the in here I need to specify metric die, and the depth I need to set as 100 millimeters. The angle start is 0, and what I want to select is cut threads as a method, and also I'm gonna do is I'm gonna trim with the start surface. After I have done, I'm gonna click OK. So the threads have been added. In the next step, I'm gonna select the front plane, and I'm gonna look normal to it, and I'm gonna add a sketch on this plane. Okay, I'm gonna select my front plane. So in here, what I need to do is, before I do anything, I'm gonna draw a center line. I'm gonna start from there. I'm gonna go somewhere there. And what I'm gonna do is I'm gonna set the dimension for this as 80. And exit. And now basically what I'm gonna do is I'm gonna add a circle. I'm gonna go somewhere there in the middle. I'm gonna drop it in here. I'm gonna set the diameter as 80 millimeters, and what I want to make sure is the center of the circle is right in the middle. To do that, what I'm gonna do is I'm gonna add some dimension here. This one will be 12.5. Control Z. Okay. The next thing, what I'm gonna do is I'm just gonna delete this dimension. I don't want to just over define my sketch. I'm just gonna drag and drop this right there. I'm gonna drag and drop this one right here, and I'm gonna select this point, and I'm gonna hold my control key. I'm gonna select this one, and I'm gonna make it coincident. And as you notice, my sketch is fully defined now. So now what I'm gonna do is I'm gonna do some trimming, because I don't need this section on this side. So I'm gonna just delete that one, and I'm gonna go to feature, and I'm gonna create a revolve boss base, and I'm gonna select OK, that I would like the sketch to be automatically closed. And I'm gonna revolve the sketch that I created by closing it around the center line to create a sphere, and I'm gonna rotate it by 360 degrees. So this is done, and I can just change the angle so that you can see how your part looks. Now I'm gonna make a couple of cuts. To make the cut, I'm gonna use the method that you have used before through reference planes. To do that, what I'm gonna do is select this right top plane, and I'm gonna add a reference plane.
Gonna go to Insert and Reference Geometry. Gonna click Plane. And the distance to create that plane, I'm gonna add as 40 millimeters. Now I'm gonna add another plane on the other side that I will use to make the cut on the opposite side to this plane that I have just added. To do that, I'm gonna go back to Insert Reference Geometry, Plane, and in here I'm gonna select top plane again. But in this case, I'm gonna flip the side where I want to add that plane, and the distance I'm gonna specify as 15 millimeters. So I have now two planes added. I'm gonna use them to make the cuts. To do that, I'm gonna go to Insert, Cut with Surface. Plane 3 I have already selected. So basically it's gonna cut in this direction. And let's complete that. And now I'm gonna make the cut using this plane. Insert, Cut with Surface, and I'm gonna flip the direction of the cut, because if I use this side, it's gonna remove all this part. And I'm gonna click OK. And I'm basically gonna hide the planes that I don't want to see. So this completes the ball joint. And I'm gonna save this file. Now to start the next part, I'm gonna open up a new document, vendor part file, and I'm gonna click OK. And I'm gonna change the units. I'm gonna change the units as mmgs, and I'm gonna save this file as, and this will be the this component will be called gear component, and I'm simply going to change this student ID so that my original part doesn't get deleted. I'm going to put some student ID, for example, this there. So I'm going to save this. To start the part model, I'm going to select top plane, and I'm going to click on this 2D circle icon. And I'm going to create the 2D sketch. And 2D sketch is very simple. It's a circle in figure 46. The diameter for this circle is specified as 40 millimeters. And I'm going to extrude this one by 26 millimeters depth or height. And I'm gonna click OK. So the cylinder has been added. Now I will make the gear profile. I will create a 2D sketch on it. So I'm gonna click on this face, and I'm gonna look normal to it, and I'm gonna click on sketch, and I'm just gonna zoom out a bit. So the first thing I'm gonna do is I'm gonna click on somewhere here, and I'm gonna do the convert entities, and I'm gonna select this, and I'm gonna click OK. So I have one circle in here, and I'm gonna add another circle. I'm gonna start from here, I'm gonna drop it somewhere there, and I'm gonna add the dimensions for this circle as 50 millimeters diameter. And now what I'm gonna do is I'm gonna add a center line. I'm gonna start somewhere there, and I'm gonna end my center line there. And what I'm gonna do is I'm gonna add one of the lines coming from here, and I'm gonna drop it somewhere there. And I'm gonna escape. What I'm gonna do is I'm gonna mirror this line across this line, and I'm gonna click OK. And what I'm gonna do is I'm gonna add some dimension here. Before adding the dimensions, I am gonna do some trimming. So the trimming that I'm gonna do is, I will not need this part, I will not need this part, I will not need this part, I will not need this part. So what I'm gonna do is, I'm gonna add some dimensions in a way that I'm gonna bring this one and drop this point here. So what I'm gonna do is, I'm gonna select this, select that. The distance between these 2 points I'm gonna set as 3 millimeters. The diameter is already set. Basically, the next thing I want to do is, I'm gonna grab this point and I'm grab this point, and I'm gonna add a horizontal dimension there. The horizontal dimension I'm gonna add is gonna be 12 millimeters. But if you notice, this has shifted on this side. So what I'm gonna try to do is, I'm gonna add a relationship there so I could make this point and this center line as coincident. Let's try to do that. I'm gonna get out of this. I'm gonna browse over in here, and I'm gonna select this point, and I'm gonna select this center line, and I'm gonna make them coincident. So as you can see, it has fixed the profile and my sketch is fully defined. And what I'm gonna do is, I'm gonna extrude this profile. To do that, I'm gonna go Extrude Boss base. I'm gonna change the direction, and I'm gonna go 26 millimeters, and I'm gonna click OK. And now what I'm gonna do is, I'm gonna use a circular pattern and I'm gonna copy this extruded Boss Extrude 2 that I have just added. To do that, I'm gonna go to Features, Circular Pattern. The direction, I'm just gonna select this edge. The number of instances that are needed are 10, and they need to be equally spaced. This is completed in your figure 49, and I'm gonna click OK. So the result looks like that. So this will be the gear. The next step, what I'm gonna do is, I'm gonna add a sketch. I'm gonna click on this face and I'm gonna look normal to it. I'm gonna sketch a circle. The center point is right there, and I'm gonna add the dimension for this circle is the diameter is 10 millimeters, and I'm gonna extrude this by 5 millimeters along this direction. 5 millimeters, and I'm gonna click OK. So this side has been made, and now I'm gonna create 100 millimeter extrusion that will be pointing towards the opposite direction. So basically, to do that, what I'm gonna do is, I'm gonna select the same sketch that I have. I could use that, and I'm gonna create extrusion, and I'm gonna select from surface there, and I'm gonna select from surface over here. I'm gonna select this face, and I'm gonna specify the direction as the dimension as 100 millimeters, and I'm gonna flip the direction. So that's done. I'm gonna click OK, and now I will add a ring around it. To add the ring, what I'm gonna do is I'm gonna select this face, and I'm gonna look normal to it, this face, and I'm gonna click sketch, select this face, and on here I'm gonna add a circle, and I'm gonna set the diameter as 50 millimeters. Alright, I'm just gonna rotate this model a bit so you can have a better look at it, and I'm gonna go to features, and I'm gonna add an Extruded Boss. In here, the method I'm gonna use is offset. Method, and the distance I'm gonna specify as offset distance is gonna be 14 millimeters, and the thickness for that for this extrusion is 5 millimeters, and I'm gonna click OK. So this basically completes your all the components that you need for the assembly.
Now we'll start the assembly for your Lab 2B exercise. To start, I'm going to go to File, I'm going to select New, and I'm going to select Assembly. I'm going to click OK. The first thing, it will prompt to bring in the first component. The first component I'm going to bring into the assembly is the cylinder rack. I'm going to open it, and I'm going to position it somewhere there. And I'm going to change the units to mmgs, and I'm going to save this file as I already have this assembly before, but I'm just simply going to call it differently so it won't affect my original file, and I'm simply going to save as that. And the next component I'm going to bring in, I'm going to go to the assembly tab, I'm going to click on insert components. I'm going to bring the gear cover. So I'm going to select here, and I'm going to place it there. And I'm going to add the mating constraints between these two components. I'm going to click on mate icon, and I'm going to select this cylindrical face. I'm going to select this cylindrical face, and I just want to make sure that I'm aligning it properly. I'm going to click OK, and I will just rotate it around to position it. In a way, yep, this is exactly where I want it, because I'm going to place the pinion gear here, which will mate with these teeth on the rack. So as you can notice, my gear cover is rotating around, so I just want to lock it in so that it only moves along this direction without rotating. To do so, I'm going to add another mating relationship. We can add mating relationship between the face features, edges. Also, we can add the mating relationship between the planes for two components. So what I'm going to do is I'm going to go to the rack component, and I'm going to select the appropriate plane from there. For example, I'm going to select the right plane for as my first reference, and for the gear cover, I'm going to select the appropriate plane as well. So I'm going to select top plane in there, And these planes may be different in your assembly, depends on how you have created your component. Just make sure that you add the appropriate relationship with the within your assembly. So I'm simply gonna click OK to that. So now I'm gonna exit the mate dialog, and I'm basically gonna test it out. Now I see this cover only slides along the rack cylinder. Now I'm gonna bring in another component. I'm gonna click on Insert Components, and I'm gonna bring the gear component into the assembly, and I'm simply gonna drop it there, and I'm gonna add some mates. So basically the first mate that I'm gonna add is I'm gonna select this face. I'm gonna click on mate, and I'm gonna add select, for example, I could go and I could select this face, and this is not the orientation that I want to have the concentric, so I'm basically gonna flip the do the alignment on the other side, so this way would be fine. And I'm gonna click OK to that, and I'm gonna move this gear around this direction, and I'm gonna add another mate. I'm basically gonna select this edge, and I'm gonna zoom in, and I'm gonna select this edge, and I'm gonna make them coincident, and I'm gonna click OK. So now I'm gonna exit the mate dialog, and if I move this in and out, I am able to move the gear cover and the gear assembly. The next component that I'm going to bring in is the last component, which I'm going to click on Insert Components. And the last component that I need is a ball joint. I'm simply going to bring it here and drop it there. And I'm going to click on the mate icon, and I'm going to select, try to catch this edge. And I'm simply going to select this edge, and I'm going to add a concentric relationship. The next mate that I'm going to add is I'm going to select this face, and I'm going to select this face, and I'm going to add a distance mate. And I'm going to click on this distance, and I'm going to specify the distance as 50 millimeters, and I'm going to click OK. And now if I move this around, I am able to move this. So now I'm going to add another relationship between the plane associated with this ball joint. So I'm going to expand from the feature manager. I'm going to go to the ball joint, and I'm going to select top plane on this ball joint. And for the second reference, I'm going to go to the cylinder rack, and in there I'm going to specify right plane. So these are the two planes. I want to add a perpendicular relationship. For your own components, you may have to pick different planes. It all depends again on how you created your components. So I'm going to click OK. So now I have added this component, and in the next step, I'm going to mirror this components along with its mates on the other side. To do so, I'm going to click on the this linear pattern triangle to expand the component that can be added. I'm going to click on select this mirror component. As a mirror plane, I'm going to select the top plane on the rack cylinder. That's right in the middle. And the components to mirror, I'm simply going to select this. Okay. And I'm going to click OK. And there we go. So I have the two ball joints located where they needed to be. So this completes your assembly. And now I will move on to the motion simulation. So in SolidWorks, as you have for your lab 1, you have been introduced to the motion tools which are available in SolidWorks. In this study, we will do a little bit more than what we did in lab 1. So first thing first, to bring in the add-in, click on the SolidWorks add-in and tab, and from there select this SolidWorks motion. And if this is not SolidWorks add-in tab is not included on your interface, you can always go to Tools. You can bring in the SolidWorks motion add-ins, and by selecting your SolidWorks motion from here, and then click OK. So once this is added, click on Motion Study 1. And in here, the first lab, what we did, we only used the animation, which basically was not solving the true motion or equation of motions. It was not solving. It was just creating the animation. If you click on this box, you will see there is basic motion and there is motion analysis. So a basic motion basically creates a realistic simulation using assembly, made springs, gravity, and motors. But motion analysis creates the most realistic simulation, which takes into account all kind of motion objects, and it provides better results. I'm going to basically select motion analysis on for the motion study. With the motion analysis, you can do two types of analysis. You could do kinematics analysis, you could do the dynamic. With the kinematic analysis, you're basically solving for equation of motion, where there's no dynamic forces are involved, or there's no torques, there's the parameters are not calculated. With the solution, with the basic kinematic analysis, you're just basically solving it for displacement, velocity, and acceleration, and so on and so forth. With the dynamic analysis, you can even model the contact forces. You can do the full-fledged analysis by including in the external forces, and also you can estimate what the internal forces could be, and also you could export those results and do the structural simulations for your assembly. So for the purpose of this lab, I would like to emphasize one thing. Whenever you're doing any motion analysis or you're doing any FEA analysis, please always read the documentation. The solver that SolidWorks uses in the backend, it uses Atoms. You need to really understand when you're doing any analysis with respect to motion. You need to understand what are the constraints. You need to understand how it's handling the equations of motions and how it's creating the solution. And after when you get the solution, you need to use your engineering judgment to see whether the solution is correct or not. Does it make sense or not? So it is one could spend the entire course on motion simulation and the motion analysis alone. But for the purpose of this lab, we are only introducing you to these tools so that you can use it for your preliminary design validation and make the changes to your design based on the motion analysis. So without any further ado, I will basically move on and then create the motion study. So for the motion study, the first thing that I'm going to do is I'm going to right click on this orientation and camera views. I'm going to basically select this disable playback view. This basically, when you disable it, you can rotate the model around when you are basically running your motion simulation results, so it doesn't go back to the original position, and you can zoom in and so on and so forth. So the first step that for this study that I'm going to create here is I'm going to click on this motor, and for this is we could add a rotary motor, linear motor, but I'm going to follow the lab manual, which basically requires you to add a rotary motor. To add the rotary motor, you can select any cylindrical face here, and you can specify the motion type for the in the motor dialog box. There's a number of options which are available. For this lab, we are using oscillating, and under the parameter that we're going to set, the angle we're going to set as 180 degrees, and the frequency we can set as 0.2 hertz, and this angle is supposed to be 0 degrees. So these are the parameters, the motion that we are forcing on this gear. And this is the displacement profile over time, which is plotted. And I'm going to click OK. The next step is we're going to change the motion study parameters. In here, we're going to specify 25 frames per second. The frames per second, if you increase the frames per second to a higher number, it will add, it will consume more computational power. So you always have to, for the preliminary analysis, you normally start with the lower number on the frames per second, but if you need more precise motion and with the higher resolution, then you can change the frame per second to the higher number. I'm gonna click OK with that. And to solve the motion, basically what you have to do is you go to this calculate icon and you click on it, and then you wait for the solution. So now to check the solution, when I'm playing it, nothing is moving around. However, if you zoom in closely and for example, if you will notice, if I play it, this shaft is rotating. Okay. So, and I'm gonna basically simply hide or change this cover to transparent, and I'm gonna play it again. As you can see, this gear is rotating back and forth based on the motor that we have forced on this gear, but it's not moving along the rack. And the reason for that is we have not added any mates between this gear and this rack. So now what I'm going to do is I'm going to add that mating relationship. To do that, I'm going to click on the assembly tab, and I'm basically going to click on mate, and I'm going to add a mechanical mate, and in there I'm going to select rack and pinion, and for the rack I'm going to select this face. For the pinion I'm going to basically select this. And for the diameter, as per lab manual, I'm going to set this one as 20 millimeters. I'm going to click yes there. And once I have done that, I am basically going to exit this made dialog, and I'm going to come back to my motion study manager, and I'm going to click on this calculate again, and I'm going to solve the motion again. As you can see, if I play it, now the rack and pinion is working the way it was supposed to. So for the purpose of this lab, one thing I would like to mention to you is that the gear teeth, they are not created in a way that there will be a perfect match in there. So for the purpose of this lab, don't worry about it. just leave things the way they need to be. Just make sure your mating constraints are as per your lab manual. One thing that I would like you to look at is after you get the solution, there is 7 redundancies. But basically it's the degrees of freedom. You can click on it. It just basically shows you there are some redundant constraints that you could remove to cut down your simulation time and to properly model your motion simulation. So how do you remove these mates redundancy? The process is very simple. You can simply either fix the components. If you know there are some components that don't move, you can fix them manually, or you can also go to the motion properties, and in there you can check this box. It will basically replace redundant mates with the bushings. So it doesn't work all the time. I'm gonna simply see if it's gonna work here or not. Otherwise, if it doesn't work, you have to go and clean up your assembly manually. If you don't remove the redundancy, sometimes it can create some incorrect results. So I'm going to solve it again. So in here, if I will review here, now there's no more redundancy. So for the last step of this lab exercises, you're supposed to create an export video for this animation, which I'm going to quickly show you here. To do that, you simply click on the save animation icon, and you can save the video file as AVI or MP4 file. I'm gonna set it as MP4, and I'm gonna save it in the working folder, and I'm simply gonna wait till the file is exported. And once it's exported, this is where the this lab finishes. Please ensure to save on the assembly and all the components in the folder, and which will be required that you will be uploading lab 2A and lab 2B as on the canvas in a one zipped folder. And please ensure that the zip folder that you're creating, all the assemblies and the files will open properly. To ensure that, you could simply unzip it on your computer on a different location and then open the assembly files there to double check. So once again, thank you very much for watching this video.